This lesson is for Advanced Algebra, Lesson 11.6 on finding roots or zeros or solutions. The fundamental theorem of algebra is going to be our main topic for the day, even though we're not going to use it directly, we're going to use it indirectly. The fundamental theorem basically says the degree tells you how many zeros you can expect. Now it does talk about complex zeros or imaginary zeros. If there is a complex number coefficient in your polynomial, you can expect that at least one of your solutions or zeros or roots will also be complex. But the way that we typically use it is to say that the degree then is going to match the number of solutions you should expect. So when you're looking for roots or zeros, look at the degree to tell you how many of those exist. Keep in mind that from there, they're either going to be classified as real or non-real. And when we say non-real, we're talking about the imaginary or the complex ones that are mentioned here in the fundamental theorem. Remember that the real ones are the ones that you can see on a graph. Once you can see those on a graph, usually those will be in the form of an x-intercept. Then you can classify them further as being either rational or irrational. The rational ones come from that list that we made in Lesson 11.5. We'll review making that list again today in this particular video. If it's irrational, then it doesn't come from the list and you'll just say how many of those there are. So your first job is to figure out how many roots there are altogether, then graph it to see how many of them are real, and then from the real list you want to make sure that you figure out how many of those are also rational. So that's kind of the format that you're going to go in, is from how many to how many real to how many rational. The other topic for this lesson is about multiplicity. The book states that multiplicity of a root, r, in equation p of x equals 0 is the highest power of any of the factors. I think it's easier to explain it based on an example. First of all, how many roots does this particular polynomial have altogether? Well, it'll be easier if we actually answer what are the zeros first, and then we'll figure out what their multiplicities are, and then we can go back and figure out the actual degree. So the zeros come from you setting each factor equal to 0. Now 17 doesn't equal 0, so we're just going to ignore that 17 altogether. Now if I set x minus 4 equal to 0, I know that the 0 there is going to be a 4. Same thing on the next factor. What minus 11 is 0? 11. But know that that particular factor has a power of 3 attached to it, so that means that 11 has multiplicity of 3, meaning that 0 appears 3 times. So if we were to write out this polynomial more exactly or without that exponent, the x minus 11 term would actually be there 3 times. So we'd get 4 and 11 and 11 and 11. So rather than writing out the same 0 multiple times, we just say it has multiplicity. So there's 2 zeros, one of the zeros appears 3 times. So that means we have 4 zeros altogether. The other topic we're going to look at today is just trying to solve equations using the fundamental theorem of algebra, by figuring out how many solutions they are and then classifying them as either being real or rational or both. So the first thing you'll do to figure out how many solutions there are is just simply grab the degree. So the degree here is indeed a 5, so there should be 5 solutions or 5 roots or 5 zeros altogether. How many of them are real? Well, in order to figure that out, we need to graph the polynomial. Now you're not going to graph y equals, you're just going to graph from here to here. So x to the 5th minus 7x cubed plus 15x squared minus 7. So I went ahead and I graphed this already, and I had the calculator determine where the zeros existed. So just a quick review on the commands that you would need to do to figure out where the zeros are. You would graph it, and then you're going to do menu, analyze graph, and then you're going to choose 0. After you do that, it's going to ask you in this lower corner, it's going to ask you for the lower bound. So you're going to want to drag your cursor so that it's somewhere to the left of one of your zeros. So then you're going to hit your center button on your calculator, then you're going to click somewhere to the right of it. And as soon as you click to the right of it, it's going to tell you where the 0 is. Now you're going to need to do that again to find any other zeros that exist. So you might have to do that command multiple times. So in this particular one, I would need to do it 3 times, because the zeros that I came up with, or the possible x-intercepts, are negative 3.36, negative 0.607, and 0.851. So I did that command 3 times, it gave me those zeros. Now I want to figure out how many of them are rational. Since I can see that there are 3 that are real, I want to make sure to list that, because there are 3 x-intercepts. So there's 3 real zeros. Now from those 3, I want to figure out which ones of them are rational. To figure that out, I need to make my list. Quick review on the list. The list comes from the terms of the constant at the top, or excuse me, the factors of the constant term on top, and the factors of the leading coefficient on the bottom. So the constant term is 7, the leading coefficient is 1. We don't need to worry about positive or negative here because we're just going to put a plus minus in front of all of the factors. 7 has 2 factors, 7 and 1. 1 only has 1 factor, 1 in itself. So all I need to do to make my list of possible rationals is to say positive and negative 7 over 1, positive and negative 1 over 1. So there's only 4 possibilities, positive or negative 7, positive or negative 1. Do any of those numbers match with any of the zeros that I got, or any of the x-intercepts? No, they don't. Not even close. None of them are close to 7 or negative 7 or 1 or negative 1. So are any of them rational? No. So we're going to say 0. 0 of them are rational, because none of these numbers appear in the rational list. I want students to try this again on their own, same type of process. So I want you to try this question. Before you start it on your own, I want to point out one thing. This question is not equal to 0, and once in a while they will do that to you in the book. So I want you to be aware of the fact that you do need to get it equal to 0 before you begin. So in this instance, to get it equal to 0, we would need to add a negative 1 to both sides. So then this is the polynomial that you're actually going to type in when you get to the real part where you have to graph it. So figure out how many zeros there are, how many of them are real by graphing, and then make your list to figure out how many are also rational. Give that a try, pause the video, and the answer will be revealed. When I graphed it the first time, I found that 2 of the zeros were really close together, so I decided to zoom in a little bit, do Menu, Window, and then zoom in, and then hit Enter, and it should rezoom or zoom in for you to get these values spread out a little bit. Then I had to find where the zeros were, so I did Menu, Analyze Graph, 0, and I did that 3 times. And I got these values of negative 1.25, negative 0.568, and 1.39. So those are my zeros. So now let's go ahead and answer the questions. How many zeros are there altogether? Well, the degree is 5, so there's going to be 5 zeros. How many of those are real? The real ones are the ones I can see on the graph. There's 1, 2, 3 that I can see on the graph, so there's 3 that are real. Of those 3, how many of them are rational? Well, I need to make the rational list, and I haven't done that yet, so let me show you how I created the list. Remember, the polynomial had been modified so that it was equal to 0. And so the constant term is 1, the leading coefficient is 2. The constant term goes on top, the leading coefficient goes on the bottom. The factors of 1 are just 1. The factors of 2 are 2 and 1. I put 1 with 2 and 1 with 1 to get my list. So positive and negative 1, positive and negative 1/2, those are the possibilities for the rational number of zeros. So do any of those numbers that I got on the graph match with either 1, negative 1, positive half, or negative half? Well, maybe this one's equal to negative half. So to test it out, you just basically type in 2 times negative 0.5 to the 5th minus 3 times negative 0.5 cubed minus negative 0.5 minus 1, and see if you get the number 0. And you'll find that when you type in negative half, you don't get the number 0, so none of these are from the graph. So none of the real zeros are also rational, they must all be irrational. So there's 5 real zeros because that's the degree. There's 5 zeros altogether because that's the degree. There's 3 real zeros because I can see where they cross the x-axis 3 times. And none of them are rational because none of them match with the numbers in the rational list that I made.